Mr. Rajiv Goyal. He is the president of Vivani Consulting Private Limited with over 28 years of experience in the power distribution industry. His career includes a 21-year tenure as vice president of power trading and projects at Noida Power Company and a 3-year consulting role to the chairman and MD of UPPCL in Lucknow. He has designed electricity distribution network for multiple cities, including Aurangabad and MIHAN SEZ in Maharashtra, and has developed almost 80 SCADA-operated substations in minimum spaces. He will present a talk on how to design new substations while upgrading the existing substation. Let's welcome Mr. Rajiv.
We all know that almost 1.5 lakh crore rupees they are going to be invested by all the discoms under the scheme of Government of India RDSS, and I expect almost 20,000 crore rupees are going to be invested in the substation. So I'm just showing a figure, a picture on right of the window, and it can be brought. Yes, and I think there are two pictures. There's the one picture which all must be thinking that some kind of mall. Yes, it is a shopping mall. It is a shopping mall of Kolkata, and that's called the Quest Mall, one of the most costliest mall in the East India. And the next figure, the point here is that there's no issue that if we show one picture of the 5 pictures. The one picture which I have shown is the Quest Mall. But my friends, this is not only a mall. It is a 132 kV substation. So the purpose to show this picture was the way we always think in our mind that what should be the substation. It is always kind of shabby picture. Always can be a shabby picture. A switch yard, a long switch yard, a hall, a dirty, people are sitting there, the dirty toilets are there, they come in the control room, a table is being placed, a substation operator is there. So what happened that India was a poor country. Yes, today also it's not a rich country, but again, in 1917 or 80s, the kind of designs were made by the electricity boards. Unfortunately, even today, the same kind of designs are going on into the India. If we have to come around into 21st century, we want to have the data centers, we want to have an uninterrupted power supply, we need to change our mindset also. And that mindset, the first thing is that the people need to understand the design. The design should be, first of all, electric substation is a factory of your business. For any distribution business, it's a factory. One must understand that factory should be very aesthetically good factory. If you go to the Nagpur, SEZ, MIHAN, you will see the same kind of pictures of the electric substation. If you go to the Greater Noida, you will see the same kind of pictures of the substation. Nowhere you can actually find out where is the substation, because the substation is actually either representing a mall, an office, or something kind of that. So why can't we think like that? That today the Government of India is planning the railway substation in a manner that it will be a city center for the businesses. So that is the way we have to design our substation. And yes, we can design with the kind of technologies are coming up from Siemens, ABB, Hitachi, the many other companies, Schneider. So we can actually have the safety is the another factor which we must include in the substation design. Presently, you must know that there are so many accidents are happening in India. Almost, more than 20,000 people die in electrocution only because of these faulty designs of 1980s. People do not know which breaker to be operated and which breaker has to be switched on. The earthing is designed in a manner which used to design in 80s. That today the entire earth soil has changed. The water component has changed. There are a system wherein we can provide the designs from the software. We can have reviewed this earthing every year. So these are the certain factors. There is a harmonic is generating a lot because of the electronic components have come into the picture. We need to done away these harmonics, and we have the relays which can actually not only operate but communicate. We have the system for the data logging to analyze those things. We have the communication system which can actually also provide a facility of the self-filling to the substation to the equipment. We have the GIS kind of technologies wherein within a 800 square meter we can actually build 2 into 12.5 MVA to 2 into 12, 2 into 15 MVA, 16 MVA transformers, substations in a space of 800 square meter only. We can have the panels on a duplex kind of structures. On the ground floor, we can have 33 kV, 11 kV. On the first floor, we can have a LT structure. On the third, fourth, fifth floor, we can have the offices. We can have the shopping complexes. So my point here was that we are going to have a uh, lot of battery storages. We are going to have a lot of solar kind of things. So we should have the facility and to incorporate from the downstream to the substation. Now, everyone talks about the what will be the cost. I am here to say that with the technology which is coming to the picture nowadays, it reduces the space cost so much lesser that actually the people can come and provide substation as a service. There are in the every city you will find all 33 by 11 kV substations. They are located at a corner points, and these corner points are a the major chunk of the property, the real estate development kind of thing. We have given a plan to one of the state governments that you give in 2 or 3 of your cities some 5 or 10 substations. We will build up. I mean, we meet our clients. They are saying that they will build up the entire substation once again using the 5 times of the space for their commercial purposes, and these substations will be free from any manual intervention. No person will be there on the substation, no person for the operations, all operations through the command and control room. This will be the safest way of doing the work where we can save the human life also. Why should a person go to a substation inside a control room? All operations can be done through the SCADA control. All data logging can be done through the meters remotely also. You can give the command from the control room for self-filling of the relays to the breakers. You can balance the load of the transformers. So many good technologies are there in your hand, but we are not there to implement those technologies only because our mindset has not changed. We are still following the 1980s of the drawing. So people in the government, because the power distribution is mostly in the government sector. So people in the government sector, when they are putting up so much of 1.5 lakh crore rupees in the system, so they must be sensitized that look how a substation should be there, how we can actually reduce the space requirement, how we can save the human life, how we can actually improve the quality of the power, how we can eliminate any harmonic which will actually reduce the losses also, technical losses also, how we can actually use the communication technologies wherein even the equipment will, before failing, it will say, I am failing, please come, please repair me. And this modern technology helps reducing a lot of repair and maintenance expenses also. Now the point is, one is the sensitization of the government. The second is that the technology should come at a price which is affordable by the utilities. Now affordability purpose, when we say the affordability means it is not possible that a GIS panel which is costing to the 10 lakh rupees will reduce to 5 lakh rupees. No, it is not possible. We must come with a solution, probably like the investors which are coming into the solar or the wind industry. The same kind of investors can come and then they say that you use the substation and pay on monthly basis. So that is the way the utilities will be able to adapt these technologies much faster. And when they use this technology much faster, definitely I understand the cost will also come down. The another point was I wanted to say that solar and this battery, these are going to be a major part of the systems and distributions across country. We cannot simply done away with the solar and the batteries. So when we design a substation, along with the safety and aesthetics, we must also consider the supply reliability. And supply reliability does not mean only with the reduction of the outages. It also means that we are able to remove the inverters from the home. And for that purpose, along with the substations, the upstream network up to the 132 kV or 66 kV or to the 220 kV substation, so that also need to be made underground. So these are the two important parameters of our electrical distribution system, wherein the government of India, when they are putting up so much of 1,50,000 crore rupees of amount, and they can actually monetize the old assets of 33 by 11 kV substations. I understand as a case study I had taken in a city like your Ludhiana. So we had gone there. We found that it's the 66 by 11 kV substation. It was having almost 2 acres of the land, and the real estate developer, he actually said that he will not only redesign the substation, provide the double of the capacity to the electricity company, but they will also provide some 10-20 crore rupees as a premium to the government of Punjab. So we can understand what kind of potential for the all power companies and for all the industries which are in the field of power distribution, manufacturing kind of products. So they all have the win-win situation, and we should actually work on that kind of system. Thank you.